Hi, welcome to video 8.1 Acids and Bases. By now you should be able to balance chemical equations. You should also be able to predict products based off of their charges. And lastly, you must be able to name acids and bases. So looking at this question here, it says how many bonds can each of the following elements make? Now remember, your charge is equal to your number of bonds. So all of this family has a +1 charge, followed by a +2, +3, +4, -3, -2, a -1, and 0. So if you see hydrogen and lithium, they're in this family over here, which means that this can just make one bond. Oxygen is located over here. This means that oxygen, because it has a charge of -2, can make 2 bonds. Now remember, we are ignoring the sign when determining the number of bonds. So if you see nitrogen, nitrogen has a -3, which means that if you guessed it, it can just make 3 bonds. All right, so here are your objectives for this video. By the end of this video, you should be able to identify and explain electrolytes. Now I put electrolytes, the basic definition, in red because as you further enhance your studies in AP chemistry, things begin to get a little bit more advanced than what I will be covering today. Next, you must be able to identify acids, bases, and salt with their properties using the Arrhenius definition. Lastly, you must be able to describe and write acid-base reactions. All right, so when you look at your acids and you look at your bases, what acids have and bases don't is that all acids have an H in front, while bases all end in OH. So whenever you see an H in front of it, this is going to be an acid, and whenever you see an OH in the end, this is going to be your base. And it's important to understand as you see different molecules and compounds throughout this unit, you're going to see that sometimes there's no H in the beginning or an OH in the end, and that's because we are going to use different definitions to define those. All right, so your H plus has a name, and that H plus is simply called your hydrogen ion. Now your H3O plus is simply your hydrogen ion attached to a water molecule, so this is going to be known as hydronium. Lastly, you have your OH minus. This should be called hydroxide. It's super important that you memorize these because we're going to be using these pretty much this entire unit, so know them by heart. Now remember, the hydronium ion is a hydrogen ion attached to a water molecule. Okay, so here's some properties of acids. Well, acids produce H plus or H3O plus ions in water. They also taste sour and burn your skin. So examples of this can be lemon or grapefruit. They also corrode metals. Now the word corrode simply means to damage or destroy. Next we have acids that are electrolytes. Now there's different type of electrolytes that I told you we're going to be studying further. But for now, all you need to know is that an electrolyte simply is something that dissolves in water and produces ions. Next, it's important to understand that acids, when reacting with a base, they form a salt and water. Now, whenever you form salt and water, this is known as a neutralization reaction. So, whenever you have a pH less than 7, this is also going to be an acid. Lastly, you have litmus paper. And if your litmus paper turns red when dipped into an acidic solution, you know that you have an acid. Now, if you already have a red litmus paper, then the litmus paper isn't going to turn any more red, but it will stay red. So, it's important to understand that. All right, so here's some acids and how we use them in everyday life. Well, acids are basically cleaning products. You also have acids that you can eat, such as citric acid, oranges, lemon, limes, lemon head, sour and patch. You eat so many of these, it is crazy. Next, you have ascorbic acid. This is just basically vitamin C. Lastly, we can use acids as fertilizers. So you see this with sulfuric acid, which, by the way, sulfuric acid is also used for car batteries, so be careful with that. So here's some properties of bases. Bases produce OH ions when dissolved in water. They taste bitter and are chalky. They are also able to produce electrolytes, which, again, what did electrolytes mean? Well, hopefully you said electrolytes are simply forming ions when dissolved in water. So bases are also going to feel slippery and soapy. Now, this is where the word saponification comes from. Now, it's important to understand what saponification is. Saponification simply just means when reacting with fats, it produces some type of soap. So bases are when you have a pH greater than 7, and they turn red litmus paper blue. All right, so here are some uses of bases in real life. Well, you can also find bases as cleaning products. They clean things such as dirt and grease. You can find them in materials such as chalk, soap, ammonia. And here's a fun fact. Your blood itself is a basic solution, which just means that you are probably going to be above 7, but more To be more precise, blood usually has a pH around 7.2 to 7.4. Oh, so here's some common Arrhenius bases used in chemistry. You got sodium hydroxide, potassium hydroxide, and you guys should know how to name these. Remember, if you cover up this right here, if you cover up sodium hydroxide, you should just say sodium hydroxide, potassium hydroxide, barium hydroxide, magnesium hydroxide, aluminum hydroxide. Remember, you just named the first element which you can find on the periodic table. And you should now know that OH is hydroxide. So you put the two and two together and bam, there you go. Now in chemistry, we as teachers love to throw in not the chemical name, but their more generic name, how you'll see them in everyday life. So another way of saying sodium hydroxide is by saying lye. Another way of saying potassium hydroxide is liquid soap. So just make sure that you familiarize yourself with these right here. You're probably going to be asked one question over this. All right, so Arrhenius definitions of acids and bases. Well, an Arrhenius definition says that whenever you take your H plus and you ionize it in water, you should be able to increase your concentration of H plus. So as you can see in this following reaction right here, all I'm saying is that as you increase your H plus, this just means that you have a stronger acid. So basically, the more number of hydrogens you have in the front, the stronger your concentration of the acid is going to be, okay? So when you take HCl and you dissolve it in water, so you're going to throw it in water, this little line right here means that you're going to ionize it or dissociate it. This means that you're going to now separate the molecules from each other and form these ions. Because we're forming an H plus ion, this makes them an acid, and then the Cl minus is going to be the separation between the HCl. All right. Now a base, on the other hand, is something that's going to increase the OH concentration, aka your hydroxide. So when you dissolve it in water, you're going to get something like this. When you take sodium hydroxide and you separate it or ionize it, you get Na plus, and then you get OH minus. Now remember, another word for base is alkali. So anytime you hear the word alkali, we're talking about bases. And the reason why alkali are bases is because, well, when you look in the periodic table, you're going to see that your alkali metals are going to be your positively charged particles. Now remember, just ionize and dissociate a molecule and you're either going to form an H plus or an OH minus. All right, so let's continue our definition between Arrhenius. And Arrhenius also tells you that when you look at the two and you separate them, you must be able to ionize them. So could you do this yourself? Could you take HCl and form your ions? Well, hopefully you answered yes, and that's pretty simple to do. Your charge on hydrogen is +1, your charge on chlorine is -1, so you should get H plus and Cl minus. Let's do a couple more. Your charge on hydrogen, once again, is a plus. Your NO is going to be a minus. Now remember, if you don't know these, if you don't have your polyatomics memorized, that's okay. Remember, it's just hydrogen, and hydrogen is always +1, and you want to get this total molecule to be 0. So if this is +1, and you only have one of them, this must be -1. All right? So you look at this guy, and this is what I'm saying. Here's sulfuric acid. Now, when you look at sulfuric acid, you have 2 hydrogens, right? Now, because you have 2 hydrogens, this means that your overall charge is +2. Remember, it's still +1, but you have 2 +1, so this makes them a +2. Now, if you only have one SO4, remember, you want to get this to be 0, so if this is a +2, and this is and you only have one of these, this must make him a -2. So hopefully you see what I'm saying. All right, so your H2O could also form H plus and OH minus. Now, when you look at your barium hydroxide over here, this is a plus. Look, without having a periodic table in front of you, you should be able to understand that OH is always -1. You have 2 -1s. That must mean that barium has a +2 charge over here. So you should get +2, -1. All right, next we have lithium hydroxide. Well, it's +1, -1, so you get plus and minus. And then you form H2O again, so you get +1, -1. Now, look, what I really want you to get from this slide is, 1, you must be able to separate them, dissociate them into the ions. This is also known as ionization. But secondly, it's important to understand that H2O, water, acts both as an acid and a base because it forms H plus and OH minus. So be very careful with that one. All right. Next, let's talk about neutralization reactions. Now, a neutralization reaction is simply when you combine an acid with a base. Now, whenever you combine an acid with a base, you are always going to produce water and salt. And now, if you're wondering what a salt is, now this is actual table salt. But when I say salt, I don't really mean just table salt. I mean that salt is simply when you have a metal and a non-metal. Basically, you have a plus charge and a negative charge coming together. Okay, so when I say neutralize, this just means that they are no longer going to be corrosive or cause any type of harm to you. Okay, so you can see that your body actually works like this in real life. In real life, your stomach is a buffer. And whenever you consume, and when I say buffer is whenever you consume an acid, it's going to neutralize that acid so that it doesn't affect your entire system. Because remember, think about it. If you kept eating a bunch of acid, well, what's going to happen is, well, wouldn't your entire body begin to burn? And the answer to that is, well, sure. And this is why you need a buffer to buffer out that solution. You can say the same thing about a base. So whenever you consume a base, the buffer is then going to neutralize that base so it doesn't affect your body. Okay? So it's important to understand what a neutralization reaction is. So just to recap, a neutralization reaction is simply an acid and a base. When combined, will always produce water and salt. It's simply, salt is simply a positive and negative charge, also known as a metal and a non-metal coming together. Okay, so your turn. I want you to label the acids, bases, and salts. So pause the video and try it on your own, but hopefully you've concluded that this over here has an H in front, so this is going to be an acid. This has an OH in the end, so this is going to be a base. This is H2O, so this can be an acid or base, so let's not look at him yet. But then we got lithium sulfate. Well, lithium is a positively charged particle. This is a minus charged particle. This must be your salt, so this must be your water. And I didn't label that, but that will be your water. Next, you have OH, so this makes your base. Then you have a hydrogen in front. That will be your acid. Then you have KNO3. Now this is positive and this is negative, so you're going to have a salt. And then you have H2O, which is just your water. All right, so I want you now to be able to predict the products. So in order to do this, it's important to start focusing on your charges again. Remember, sodium has a +1 charge, while oxygen has a -1 charge, and hydrogen has a +1 charge, and fluorine has a -1 charge. So remember, opposites will always attract. So you're going to take your positively charged particle, and you're going to combine that with your negatively charged particle. So your +1 with your -1, which is simply going to give you NAF. So you're going to get NAF over here, plus you're going to do the same thing. Your metals, your positive charged particles always go first. So you're going to take your hydrogen, combine it with your OH, and you're going to get H2O. So you should get H2O plus NAF. Now we're going to do the same thing for this one. And I already have these charges here for you guys in case you don't know this is -2. You're going to take calcium. Calcium is +2, hydroxide is -1. So when you combine them and you crisscross, remember we're doing that whole zombie method stuff, but when you crisscross this +2 goes with this -2, so they're going to offset and you get CaSO4 plus H2O. All right, now make sure that your compounds with the crisscross rule are equal to 0. If they don't equal to 0, you did something wrong. So notice the overall charge on this molecule is 0, the overall charge on this molecule is 0, this molecule is 0, and this molecule is 0. So make sure that they should always be equal to 0. All right, so that pretty much sums up the Arrhenius acid definitions. Now there are some limitations to Arrhenius definition, and one of those is, well, what happens if you have an acid or a base, but there's no H in the front or OH in the end? So for instance, if you see ammonia over here, ammonia is a base, but notice there's not an OH in the end. It's simply just an H. So whenever we talk about these limitations, this is when we move on to our next definition. So be ready to see that in our next video coming up today. All right, so we're going to end there, guys. Hopefully you guys got something out of that. Remember, guys, stay safe. I care a lot about you guys, and we will see you in this next video.